Oh, that's weird. It shows my mouse. But it's, that's not actually where it's at. Is YouTube messed up? Oh, finally. How's it going, Johnny? Nice. Whoa. Got a brand new look. Alright. I know that it's worth quite that much room in the interface, but... Right. Just wrangle a couple of these windows. There we go. Alright. Welcome. Good day. Happy Saturday. For anybody that might be new, my name is Tim. I go by FoamyGuy on GitHub and Discord, and I'm typically working on CircuitPython stuff on this stream, broadly speaking. If you are new and you don't know what CircuitPython is, you can learn more at the main website here, circuitpython.org. This is basically a version of Python that runs on microcontrollers, which we can find a bunch of pictures of over here. Basically, these devices will plug into your computer like a thumb drive. It will show up as a little, drive. You can edit some code files on there, and then there's a Python code file that you can write whatever code you want to. Then this microcontroller will edit it. Did I say edit it? It will execute it, rather. Lots of these different microcontrollers come with I/O pins, which you can connect other electronic devices to, whether it's like sensors or buttons or beepers or lights or buzzers or levers or knobs or pretty much any kind of little electronic widget you can imagine. You can connect up with these things, and then if you're using CircuitPython, you can write some Python code to interact with that widget. These microcontrollers do come in all different shapes and sizes. You can see on this page, we have just shy of 500 different boards that support CircuitPython. And if you take a quick scroll through this page, you'll see there's like all different ones. Some of them have built-in screens. Some of them are like mini handheld gaming things. Some of them are just small and utilitarian with only a couple of pins. Some of them have network access. Some of them have Bluetooth. Some of them have alligator clip holes, like all kinds of different variations of these things. But these can all run CircuitPython, all the ones listed here on the downloads page at least. CircuitPython is open source. Anyone's allowed to use it. Anyone's allowed to put it on your own microcontroller. Even if you are like a company that manufactures your own microcontrollers, you're allowed to use CircuitPython on that device if you want. Adafruit, which is the hardware and software company based out of New York. Adafruit is the one who is providing the financial backing for CircuitPython by paying the developers who work on it. So their website is adafruit.com. They design and manufacture hardware over in New York, and they have many of the actual microcontroller devices themselves. You know, if we search for something like Feather, we're going to see a bunch of the different microcontrollers, although in this case, those are actually unexpected maker ones. If we scroll a bit, or maybe if we search Adafruit Feather, or if we just keep going through pages here, we'll find all kinds of different Adafruit microcontroller devices. But another thing you can see is they also have all of the kind of peripherals and things that you can plug into your microcontroller. You know, expansion boards and breakout boards and sensors and all the RGB LEDs you could ever imagine. So you can buy that stuff from them. If you do that, you're helping support CircuitPython, so huge thanks for that. And as always, huge thanks to Adafruit for paying the folks who do work on the project, because that, you know, obviously is like making it possible to continue evolving it year after year. How's it going, C. Grover and Tyeth? Yep, definitely coffee reminder time. I got mine here. And then before I dive in today, I wanted to say kind of hug report / shout out / thanks to JP. I noticed that the CircuitPython parsec this week was actually the circup examples command, which we were working on like last week and the week before. So if you're interested in that command, you could actually go back and watch some of the prior streams if you want to see the actual development of that command while it was in the works. But I just wanted to show that that was there in the parsec. This was just released yesterday. So if you want to learn about that command in a quick little bite-sized parsec, then check that out on YouTube. You can search up CircuitPython parsec, or you can go to Adafruit and find the playlist for it. It's a really nice, quick look at what that command is and what it does and how it can be helpful. So huge thanks to JP for making that the focus of the parsec this week. That was really cool to see. Jumping into the actual thing I want to start with to work on, let me get a couple of these wires. My desk is kind of out of control right now. I got to get some desk wrangling action going on. Yeah, I have so many things. I have microcontrollers and sensors. You can't see as much of it where this camera's at, but just out, rest assured, just outside this frame, it's like a pile of microcontrollers and wires, buttons, and all kinds of things. All right, so I have here a, let's get it turned around. I have here a Badger. Could maybe put some light on. It's a little stormy here today, overcast, which makes it rather dark in the room that I'm at. Let's see, where did the control panel go? There it is. Blink. Okay, it's a little glare. Maybe we can use, we slightly carefully shift the pile. Can maybe have access to one of these things. Okay, so I have a Badger 2040W. It's a Pimeroni device. So this is a kind of like a conference badge aimed piece of hardware. It's got a Raspberry Pi Pico on the back. It's got an e-ink screen on the front. It's got 5 buttons. And it's actually, though it's a not a Raspberry Pi Pico, the original, but it's actually rather a Raspberry Pi Pico W. So this device does have internet access, which will be somewhat important for what we'll be doing with it here in a bit. It's got like battery charging, a stemma, or they call it quick, port over there. It's like, that's about it really. It's like fairly minimal, doesn't have too much going on, but it's like, that might be a speaker. I haven't messed with it, but it looks to my eye like it would be a speaker. So maybe a tiny speaker on there, but maybe not, I'm not sure. But it's just a nice little, like, you could clip it to a lanyard or whatever. You could set it up on your desk if you wanted to use it as just a little card with information on it that rotates out or does whatever, weather, something like that. So neat little device. What I am working on that is a program that does a couple of things. Let's get it plugged in. See if we can Actually twirl it around the right way without avalanching the desk here. All right, let's get the code. And I will say the code for this, if anyone is catching this in the future or live and you're interested in the code, I do have it out on GitHub. You can actually find it. Foamy Guy, like GitHub/Foamy Guy, and then CircuitPython Badger 2040W tic-tac-toe is the code for this, and I'll push it when we get done as well, so you can get the latest one. This is basically, though, a kind of conference badge one. You can put your name there. I don't have filled in right now, but it could, it could write something in the center there. Hello, my name is whatever. In fact, why don't we do that? Where would that be? Let's see. I need to also kind of, for my own sake, read back through this. How long is this? This is only a couple hundred lines. 400 lines, 430 lines. Let's take a quick stroll through this just to get reacquainted with it as well for myself, and that'll give you a chance to see it as well. I don't think I ever streamed when I was working on this, so this will give you a chance to kind of see this for the first time, anybody who's interested. It does set up the Wi-Fi. It does have an HTTP server as well, so we would be able to, if we found the IP address, we could go hit that IP address and it would return a web page for us. We'll be doing some stuff with that web page later. Let's see, we have a state machine because this program has one of a number of different states that it can be in. These are the variables that drive that. Right now there's a state for the badge, which is the one we start in. There's a state for the tic-tac-toe gameplay, and then there's a state for tic-tac-toe when the game is over. And then we have a current state, which will update as needed, and you can see there it starts on badge. Okay, so good stuff. Ignore multiple state changes if they occur within this many seconds. So this is just like a cooldown that makes it so that you can't like accidentally double click or spam the buttons or something. In particular, this is an e-ink display, which it takes a second or two to update. So if you accidentally double click and it changes twice or something like that, it can be a little bit painful. So that will try to prevent that. This will be a timer variable. This will store a time, the last time that we change states. We're at the beginning now, so we initialize it's -1. We have some colors. We have some constants for some buttons. Each one, matching one of the 5 buttons we have on the device, again, because we do have a up, down over here on the right, and then ABC along the bottom there. Grab the default display, create a tic-tac-toe group for it, create a background palette so far. So that's just a palette with one color. The color is white. Make a rectangle the same size as the display. Was nice enough to leave comments here. Thanks to Past Tim for that. Background rect. Create a rectangle, set the color palette, make it the same size as the display. Why is that warning? X unfilled. I guess it will default to 0, 0. I think that's trying to tell us, though, that it would be more proper to actually have like this. But I think those are also defaults, too, so it doesn't matter. Tic-tac-toe rec append, the background. Okay, then we have... So that's all... This is just like CodePy level stuff. Now we get into a tic-tac-toe game class. This extends group, so we're going to be probably appending some stuff to it when we're inside of here, and then later on we're going to be going, display.root group equals, and then the instance of our tic-tac-toe game. So what do we got in here? We pass in the display. We store that on a variable so we can look it up later. Probably for getting to height and width and stuff like that would be my guess, or maybe for calling root group equals again to change it to something else. I don't know. That would probably be self. We'll have to see. My guess is height and width mostly. Board lines, color palette. So that's creating another palette, one color. This one's black. Randomly decide who's first. So in the tic-tac-toe game, obviously there's X's and O's. This is going to make a random, coin flip to decide who goes first. board lines. So these are the lines that represent the actual tic-tac-toe board, I believe. We have a left line, a right line, a top line, and a bottom line. Those are actually rectangles. They use the palette we defined up there. They're like 2 pixels wide and then 118 pixels long, and they go in the different directions based on which lines they are. Okay, so that's like going to draw the tic-tac-toe game board for us. We're creating all those lines. We're appending them to self. Remember, we extend group, so we're adding those to the self group. So later on, when we get shown on the display or get set to the root group, then all these things will become visible. That's a dotted line. So selector, that is for basically it's like a cursor. We're moving that around the board to decide where we want to play. Basically, it's like a cursor. The user can move it around and then click select when they want to play in that location. That is specifically the bitmap that represents it. We're grabbing that out of the file, selector bitmap. We're making a tile grid for it. We're appending it to self. We have 2 bitmaps, one for the for the game pieces, one for X, one for O. We have a map, which is a list of lists of tuples, mapping of board positions to pixel locations. Okay, so what this is mapping is mapping the indexes within the board, like 0, 1, 2 by 0, 1, 2. So, the tic-tac-toe board, it's 3 by 3. So, and then if we use 0 base indexes, we have 0, 1, 2, we have 0, 1, 2. This is converting those 0, 1, 2 coordinates into pixel coordinates, and specifically, I believe, selector location, I believe those are the XY pixel locations where we would want to put this selector tile grid that is displaying that cursor in order to indicate that that particular square within the tic-tac-toe board is the one that is being selected or focused. It's not really selected until you press the select button, but set the starting position of the selector. That's taking random coordinates within that 0, 1, 2 coordinate space. Move the selector tile grid, so that's choosing a random location, and then that's actually setting the tile grid which holds that selector cursor bitmap. It's actually setting it at that location. Looks like we have a helper function for that. Place tile grid at board location. We're giving it the position we want it to go. We are giving it the tile grid. We are also telling it refresh false, so presumably we're going to do some more stuff on the display before we want to refresh. So that's going to hold all the X and O piece tile grids as they get played. Okay, fair enough. So we just got a list there that will hold tile grids that point to these bitmaps. Each time a new play happens, we'll create a new tile grid. We'll stick it in there. We have a 2D representation of the board state with just some strings inside of a list. The winner line polygon, that one's kind of weird. That's like at the end of the game, we want to draw a line through, the three spots that won, whether they're straight up and down or diagonal or horizontal. We want to draw that line through them. This is a polygon that will represent that line visually. And then these are a bunch of pixels that, are more or less just magic pixel locations that make the line look like how I want when it draws through all those different possibilities. All right. And that was all our init. Yeah, so everything in there is inside of init. And now we get into the reset game function. So while the length, while the length of the played pieces is greater than 0, we will remove a played piece. Remember, played pieces, that's our list of tile grids. So we're going to be looping over that list of tile grids. We're going to be removing it from 2 things, actually. We're going to be popping it out of the list. So that's going to remove it from the list. We're also calling self.remove, which is going to remove it from the group, our self instance of group that we extend. So we're removing it from the list. We're removing it from our own group. We are looping for row index in range 3, for I in range 3. We should use column here, right? Call index. Okay. Print some debugging output there. Set the starting position of the selector. So that's creating a new random location to put the selector at. Move the selector. Yep, these are the same two things we saw back up inside the init right here. These are the same two things happening, which makes sense because we would want to do the same things when we reset as we do when we start. Theoretically, I suppose init could be calling reset, but maybe that's a different story for a different time. Inside reset, we got some more printing. If winner polygon line is not none, then remove the winner polygon line. So if we have, that's another way to say that is if we have a winner polygon line, then remove it from the self group. Move selector up. So that is going to take the selector wherever it's at. It's going to move it up by 1 square. Move selector down. Same thing, but opposite. It does have bounding as well, so it won't allow you to go off the board, right? If you're already on the top row and you say move selector up, it just won't do anything. So we have down, we have left, we have right. Those are basically all the same things, just different directions. And they work by just calling that place tile grid at board location, board position, and plussing or minusing on that position index. Play piece at. So this one takes a piece, it takes a position, it takes a refresh. If the piece is X, then we create a tile grid from the X bitmap. If the piece is O, then we create a tile grid from the O bitmap. Append it to the self group. Append it to the played pieces list. Technically, this is probably redundant, but that's all right. Move the piece tile grid to the current selected position, but do not refresh yet. So place tile grid at board position. The position is position we were passed. The tile grid is piece tile grid, which we created here. And then refresh, it's actually just passing through the argument refresh. So if that was not passed, it will be the default false. If it was passed, and if it was true, then it would actually pass through true here as well, which is a little bit counter to what this is saying. But I think not refresh unless, maybe, let's say do not refresh unless refresh arg was true. I don't know if this is the right syntax. I'm going to just take those out for now. Update the board state with this move. So that's our board state. That's our list of strings. So we are basically putting an X or an O into that list of strings. Okay, play current move. Place a piece at the selected position based on whose turn it is. So when that gets called, we say play piece at, we say turn, which is piece. Let's play piece at piece. So that's going to be either the X or the O as a string. We have the location. We have a refresh false. We change the turn to the opposite player. If it was X's turn, it becomes O's turn and vice versa. Print the board state. Update the selector position to a random choice from all of the remaining empty slots. So after a piece gets played, then the selector, which is like the cursor, it's going to move to a random location of an empty tile. It won't randomly choose a tile that is occupied already. Move the selector tile grid. Yeah, so we chose a new selector location, so then we need to place the selector at that location. Nice and easy. Check winner. Winner is none. These are basically going to be doing a series of loops to check whether or not there is a 3 in a row anywhere. So that loop is going to check all of the rows to look for a horizontal 3 in a row. This loop is going to check columns to look for a vertical 3 in a row. And then this part here is going to do the 2 diagonals. It's kind of doing them both at once, I guess. It's building up a list, and then it will go through and check the list. Okay, but then when it does, if it does find a winner, it returns a tuple with the winner, as well as an identifier that says where, like which row won, basically, or column or diagonal. So it says row dash, and then the index will be 0, 1, or 2, or it's like call dash 0, 1, or 2. Or we got diagonal top left down, or diagonal bottom right up. Show winner line. So this is all a prior attempt at the winner line. This is the current code that says if the winner line polygon is none, we want to make it. We want to make a new vector IO polygon. We will give it the pixel shader for the winner line. We'll give it the points that we looked up from our mapping, that mapping that contained all those weird pixels. Those were mapped to these like location indicators or line indicators. So that's going to choose the right pixels to draw the polygon that represents the winner line that we want. We're going to pin that to ourself so that it will get shown on the display. If the winner line was not none, then we will just update its points. We'll give it a new list of points, and we'll put it on ourselves. So instead of creating it, we don't need to create it. We already have it. We can actually just update the points, and that will change the way that it looks. Empty spots, that's a property. As the name suggests, it's going to return a list of locations that are empty. I keep saying locations, but the code is position everywhere. Maybe I should have put locations in the code, or maybe I should try harder to say positions. So that's a list. We're looping over the rows and columns. We are checking if the current index in the row and column is empty. If it is, we'll add it to that list, and then we'll return the list. So that is going to be helpful for later. Earlier, the code we saw that's using it was choosing a random empty tile to move the selector to. Place tile grid at board position. We're almost done getting through the code here. I know we're reviewing more than we're writing and seeing, but this is all very helpful because it had been a couple of weeks since I really had my head in this code. So place tile grid. Okay, so yeah, we've seen this called several times. We can kind of surmise what it will do. It takes the position, it takes the tile grid, it takes that refresh. This one does actually default to true. Place a tile grid at specified position. It has bounds here as well, so if you give it a position that's out of bounds, it will print it and not crash and not update the display. If it is within the bounds, then it will say tile grid X and tile grid Y is equal to the values we got out of the location map, which was the first map that we saw. That was the map of the 0, 1, 2. Okay, so I guess I did call this location, but then we have position everywhere else. Maybe that's why I'm thrown off. It maps the 0, 1, 2 indexes into the pixels where we would be putting the selector. If refresh is true, then of course we call refresh. All right, so that is our whole helper class. So we're back to the CircuitPy context after that. We create an instance of that game class we just looked at. We append the instance of that game to the tic-tac-toe group, which was the group that we created way back up next to in the display. We looked it up at a board. It's creating, okay, a keypad for all the different buttons, up, down, ABC. creating a NeoPixel instance on the SDA pin. I don't actually have that connected, but Kattni, who will be using this badge, does have some NeoPixels there, which is why that's there. Oh, actually, the display thing is here. Is that there twice? Didn't we do that before? We did. Okay, let's just let's remove the one down here. We don't need to do that again. I don't think. Let's see, maybe it breaks it, but I don't think so. Okay, so NeoPixels. We create a badge group. We create a white rectangle based on the name, which is a rect from display shapes, which is looking like about 1/3 of the display or so. Something like that. Badge group append. A label. There's our label, which is, this is where we could put a name. We should make that a variable, probably. Color white. Okay, so that's going to be in the black stripe at the top, I think. Set state. Okay, so there is a helper function that updates our state for us. So we pass in the new state. It will change the root group accordingly. It will try to call refresh. And the importance of trying to call refresh is on an e-ink display. If you call refresh too fast, you get an exception. So this will catch the exception. It will wait for the requisite amount of time, and then it will refresh again. It's kind of just smashed at the end of the function here. Let's move that down a bit. Want 2 lines. So that is going to set the current state. So that's going to call set state on the current state, which we know from before that's the badge state. Okay, so now we get to our server setup. Everything above has been like the badge and the tic-tac-toe. When we very first started, I said we had a server running as well that we could access over the web. This is the actual setup for the server, the handlers for those endpoints. So we have a change NeoPixel color. It's a GET request. It takes RGB query parameters, and then it calls pixel fill with the color that was received. We have an index handler, which returns index.html. We have server.start just to get that server running. Inside of our while true, we call poll to make the server do its thing. We call events.get on the buttons. If we have events, then we need to decide what to do with them. If it was a pressed event, pressed buttons. Okay, so this is basically making a list of all the buttons that are pressed. So that way we could, there's going to be some functions that are like if 2 buttons are pressed at the same time. So this part here is all just building up that list of pressed buttons. Where does that get declared? There we go. Pressed buttons is a list right up there. Okay. So we do that first, and then we get into the meat and potatoes here. We say try if the current state is tic-tac-toe. So this is kind of the main chunk of our state logic, state machine logic. So if we are in tic-tac-toe, if there were key events, if button A is pressed and button C. So so this is basically like if you hold down A and then you press and release C. So hold A and then press C. Then we will change to the badge state. We will call set state. We will set the variable that says the time that we changed. Then we will continue with the next iteration instead of doing the code from below. I think that's how that works. These are basically D-pad handling. So if the up key was pressed, move the selector up. If the down key was pressed, move it down, left, right. If the select key, which is the middle one, the B key button, that B button was pressed, then play the current move. So place the actual X or O at the location this selector is on. Check for a winner. If we have a winner, print it, show the winner line, update the state, call display.refresh. It's interesting we didn't call set state here, right? It's kind of weird, right? I guess it's because the game over state doesn't have its own group. It stays in the tic-tac-toe group, but it's still a different state logically. It has different behaviors. Okay, so after that, we continue. Again, skip the rest of the code, go to the next iteration. Else, if we do not have a winner, then we just call refresh. Because remember, we are inside the select button here. So we've moved the selector around. We're pressing the select button to play a piece at that location. We checked for a winner. There's not a winner yet, so we just update the display to show the new piece. All right, if we are in the game over state, if we do have buttons, if we have buttons released in this case, if the event is released, then we will reset the game. So yeah, that's on any button there. That's not actually checking for a particular button. That's just saying if any button was released, we want to reset the game. We set the current state to tic-tac-toe. We call refresh. That's another one where, you know, we're kind of coming from game over and going to tic-tac-toe, so we don't need to call set state because we're not changing the group. Another continue. All right, if we're in the badge state, so all that was tic-tac-toe state. Now we're in the badge state. If we have a button pressed, if we have waited long enough for the cooldown, so that's that timeout to make it so that we can't switch states too quickly accidentally by like double pressing the buttons. So if we've waited long enough, then we're going to say, let's see, if the key number is either the up or down buttons, then we are refreshing. This was like a test, I think. This bit was not part of the final code necessarily, but was here to test something. What that is doing, though, is if you press the up or down button, it will look up the amount of memory that's free. It will draw onto the text on the display to say hello and the key number that was pressed. It will refresh. It will print these things. It will fill the pixels with red in this case. So this is more or less kind of like a debugging thing. Eventually this will probably get removed or changed to do something else. If the button was A though, so if we're in the badge state and the A button is released, which of course has to get pressed in order to get released. So if the A button gets pressed and released, then we set the state to tic-tac-toe. We call set state the else here. So that is if we are in the badge state and if there are no buttons pressed, then we will set the pixels to turn off. And then at the very end here, we just have a runtime error catch. This is catching our refresh too soon. And it's just waiting and then refreshing again. All right, and that is it. So yeah, sorry that was a little long, but now you and I both have a very in-depth understanding of what this code is doing. I did update it to say Blinka there, so now we have Blinka, and then we know that the up and the down buttons will change that to say hello and give us a key number, which basically corresponds to which button got pressed, either 0 or 1 in this case. We also know that if we press the A button, it should take us to the tic-tac-toe game. So there we are. The way the tic-tac-toe game works is up, down, move the selector up and down. A and C move the selector right and left, and then B plays for the current turn. So now it's the next person's turn. They could move the selector again, same way. They can play their piece. There's the O. So if we are X's, let's try to get the X's to win on the middle row there. So we'll make maybe not the best play for O's here. We'll go over, we'll go up, One thing we should do is maybe like skip past that or something. Because it like hid the selector there. All right, so we'll play the O. And then we'll play our X for the winner. And then there's our winner line that shows who won. And then we know that we're now in the game over state, and we know that in the game over state, if you press any button, it will start a new game. You just press any button like that, and now we get a new, fresh board to play again. And we also know when we are in the tic-tac-toe state, we can press, was it A and C? Yeah. Hold A and press C. And that gets us back to the badge. All right, that is where we are at now. What I would like to do is add some stats. I want to show on the game over screen, I want to show ultimately two things. But to start with, we'll say one thing, which is going to be the score. How many times has X's won, and how many times has O's won? And I'm going to call that actually the session score. That's going to be a dictionary, which is going to have, I think we use capitals. I'm going to use the same, I'm going to use the same strings we used there. Set that to 0 to start with there. So then each time somebody wins, we'll increment that score. So that's going to be like check winner is an easy place for that. Check winner. Or should we do it after check winner? Inside check winner, or we do it after? I feel like we should do it after check winner, right? Check winner should just check the winner and return it. Yeah, all the side effects should be after that, I think. So we check the winner. If there's a winner, we will go session score access the winner 0, which is going to be the string X or O, I believe. Yeah, because winner 1 is going to be that identifier like row 0 or column 2 or diagonal top left down or whatever. So session score of the letter who won, we're going to set that actually to plus equals 1. And we want to how do we want to do this? So I don't want to make a whole new group for the game over state. I don't think. Have a nice day over on YouTube. Thank you. Appreciate that, my friend. I don't know. I apologize if that was from a while ago. I actually did have the YouTube chat covered up accidentally with my OBS, so I appreciate you, though. Yeah, I don't want a whole new group because I want to just keep showing the board state, right? I don't want to hide the board state with the line drawn through it. So let's just say like show session score. Yeah, we're going to call that. Good morning, Johnny, or good evening, I should say, for you. Coffee cheers. All right. Yeah. That's gonna be inside the game or outside the game? That's gonna be outside the game. Yeah, that's gonna be outside the game. We do want a new text for that though. This is we should update this. This is the badge text, and specifically this is the top row badge text. Top row badge text. What? Oh my goodness. No, don't do that. Why would you do that? Never mind. Top row badge text. Sometimes refactor gets ahead of itself. There's a way I can tell it just this file, but just copy paste it. It's fine. Text. So then we are gonna want. Eventually, we'll probably have like middle row badge text as well, but for now, what I want is the session score text. Are these bitmap label? Yeah. I'm just gonna set the text to blank to start with, because we're in the initial, or we're actually in the CodePy context here. We're just at the outermost context, so we don't, we're not at the game over yet, so we don't know who won. It's gonna be 0-0. We're not even showing the score to start with. So we'll just say that. I will say the color is gonna be black because the background is white on the game over screen. So we have two choices. We can either use hidden on the session score text. We can set hidden to true whenever we're not showing it. So whenever we're not... Actually, I mean, we have room on the display, right? We might as well just show it all the time, right? I mean, not in the badge, but like in the game, right? Yeah, we might as well just put it over here. We don't, like, the road I was going down in my head was like, let's only show it when we're in the game over, but like, I mean, we're not using the display there. So yeah, we could even just, we could set the initial value, I guess. Let's do like session score template string. I can't, can I do an, I don't think I can do an F actually. So I want to do, let's see, we want to say X's. No, let's do like session score, new line. I do want, I think, a space X. And then we're going to say that, and then another new line, another space, and then Y, that. All right, and then we're going to be filling those in. Actually say template string format session score. And that's going to be going on the tic-tac-toe group. We probably have room to make it scale 2. And then we are going to want to give that a new location with, I like anchor point 0, 0, and anchor position. We need to get to the right of the game board, which I think is, I want to say that each like column is 40 pixels. So 40 times 3 is 120. We did like 140. We should be in a pretty good spot, I would think. But that's an anchored position, which is a tuple, which can't just be one thing. 0, let's do like 10 maybe. All right, let's see how that goes. Okay. 10 is too low, first of all. Let's back that off. Maybe even like 2, I think we could get away with, because we kind of have a bit of a border or whatever, a bit of a padding or something going there. I don't know what the darkness here is. This is kind of interesting how it's got this like dark kind of line there at the ends. Also kind of got a weird line over there now. I don't know what that's about either. Okay, I think we can. We're pretty close on. We're pretty close on the right side. I'd like to scooch to the left a bit. I don't know if we have room to go all the way back to 130 though. 130 feels ambitious. Okay. What is up with that line, I wonder? Was that there before? I'll tell you what, let's just put another new line. We have room to go down somewhere anyway. Although, now our spacing is going to be weird, maybe. Let's see what I don't know, maybe it's not too bad. So we don't see that line. Was that there before? I mean, this wouldn't make any sense. I mean, the winner line is the only line. I think it would look like that, would it? I'd be showing it anyway. In fact, it doesn't get created until you show it for the first time, so it can't be. Okay, let's do this. Let's see where we at. So when we are in the badge, we're in the badge and we go to the tic-tac-toe. After we set state, I don't know. I think of them as elements. It's not a proper term for CircuitPython necessarily, but for each element in the group, which is self, print element, I'm going to also print type. That might already be there. I'm not sure. This doesn't like self. For elements, it would be game, not self. There we go. See if it's like an object or not. I don't think it should be, but I also, since we don't see it here, but it could be getting covered up, I guess. That's a good point. It could be getting covered up, I guess. In which case we could maybe get it covered up on this one too, but we are drawing. So maybe my background is not the right size. I'm drawing a background. So we have rectangle, 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 rectangle. Those are the lines. And then we have tile grid, which is the selector. Thought we had a background. Are there 5 rectangles? 1, 2, 3. Well, that's weird. I don't know why we should. I'm pretty sure we should see 5 rectangles. But okay, I did change this, right? Thinking it shouldn't do anything. If I stand by, I don't think it should have done anything, should it? If I put that back, do we get rid of this thin? I don't know if I ever said it super clearly, but this thin line on the far right edge over there is what I'm trying to figure out / do away with. No, that doesn't make a difference. If I were to set this to like 3. Okay. So now we have a line on this side, but that's because technically our background is a white rectangle and I just shifted it over. I mean, should it start on 1 or should it just be width plus 1? Isn't that weird? That's like an off by 1 error somewhere, right? Because if we set the rectangle to the display width, I don't know off the top of my head, but is that even true? I don't think that's true. You can totally add it. I guess it's telling me I can't, but like. $296. So if you set a rectangle the width of 296, then you put it at pixel 00, which is the top left corner of the display, and then you're putting it by the top left corner of the rectangle. The display's pixel indexes run from 0 to 295. If anything, I would think this would be bigger by 1 than smaller by 1, because it might be, well, no, it should be on the nose, right? I don't know. That's weird. That makes me think there's potentially an off by 1 error inside of rectangle, maybe. Yeah, well, graph paper for me, it would be not necessarily graph paper, but just shedding everything except for the rectangles and making like 1 pixel rectangles and moving it around to various places to figure out what it does, what it doesn't do. Hello, bro. How's it going, my friend over on YouTube? Interesting. Okay. We'll back burner that one for now because I can solve it easily with a +1. But that makes me think, which also is like honestly a little bit deja vu-ish. Maybe I just need a newer version. Well, but I'm on a pretty new version, I think. This takes a minute. Okay, 903 is that's pretty new. It's not brand new. Pretty new. It feels very deja vu though, actually. Like maybe there was something like this? Oh, I didn't even know that was a thing. Location property. Is this Ubuntu? The OS that I am using on my computer is Ubuntu, yes. That seems like sort of related, maybe. I don't know. This really rings a bell though. Now that I've seen it, like I feel like either maybe somebody came in the Discord. Maybe this is it. Okay, maybe this is it. Huh. Okay. Yeah. Okay. This is why it feels familiar, because I was here before and I even validated it on non-e-ink screens. So it is, I mean, is it a... I'm a front-end developer. Nice. That's cool. I do some front-end development, but I would say that I am not necessarily a front-end developer. I am a developer of many hats, including front-end and back-end and microcontrollers and Android. So yeah, I don't know if that's actually a problem with the rectangle or if that's a problem with the display rotation, but one or the other, it seems like needs a fix. Okay, so we won't go too far down that rabbit hole. We won't go any farther than we already have, which is already kind of far, I guess. But I am gonna run to the restroom real fast, so I'll be right back. BRB. Okay. Yeah. Let us... How's it going, Bear? Coffee cheers. Getting low on mine. All right, let's make sure that does show the score. Well, I commented out, I think, right? Let's put that back. Let's make sure it actually counts up when somebody wins. Maybe I'll look into this one of these days. How come we didn't reset? Oh, the REPL. Looking for inspiration as I do UI design for my for my sensor package idea, but I'm definitely not a UI person, so it's a lot of fun learning. Nice. I would say, yeah, I'm not. It's a hat I wear, but it's not a thing I would say that I'm like good or proficient at necessarily. I've come a long way in the time that I have been programming, but I am definitely guilty sometimes of having let's call them like back-end friendly UIs, like just print everything out or whatever. Over on YouTube, I don't know how to pronounce your name. Sorry, I don't know if that's just your full name or if that's just random letters or whatever. But are you do you use Ubuntu as well for your front-end development, or you use different OS? Anybody else who wants to share your OS, that's cool too. We're not starting fights over about OSs either, though. Like, I don't really care that much. Like, it's not a thing to fight over, but just I'm curious sometimes to see what people use. Yeah. So let's get a winner. Do as quick as we can by not moving any more than we need to. Oh, I put X and Y. All right, we can make sure if it works anyway. Nope, I think it crashed. Yeah. 406. Okay, well, first of all, we never actually created this, apparently. We don't actually need to call it. That was back when I was thinking about showing it only during the game over, but we changed it to just show it all the time. This is no longer text. Wow, I don't know how this stuff was even running. This is now what? This was like top text? Yeah. And then, is it 406? I put them wrong in here as well. We need X and O, not X and Y. We need that in the label too, which is split. Is that an O or a 0? My problem, let's see, good them have them all on hand. Windows for work by default plus WSL. Ubuntu boot by default. Separate old gaming Windows laptop with Pi and Intel Mac. Nice. My problem is enhanced by my goal to use both LCDs and e-ink. Ah. Yes. That does make it tougher. With CircuitPython especially, it's tougher because you're in dual display territory, which is like kind of supported and by the core, but also not necessarily like officially supported by any real hardware. So it doesn't get used very much, and so it does tend to get broken and then not noticed for a while. Any kind of dual display stuff. But if you separate them, like if you connected them via serial or something and had like coprocessor type thing going on, you could alleviate the need for actually having one CircuitPython device with two displays. But theoretically should be possible though, as long as your displays are on like I mean, ideally different buses. Technically, maybe it could be the same bus with different chip selects or something. I don't think I've ever tried that, though. But why here as well? At least I'm consistent, I guess. Ubuntu, Mac OS for home, AWS, Linux, Mac OS, Windows for work, microcontrollers for both. Nice. I don't get into a lot of Windows these days, although I have, like, it's a reoccurring theme in my work life that people ask about a Windows version of the primary piece of software that I work on, like outside of CircuitPython work. I think we've been asked probably half a dozen times, if not more, over the years about a Windows version. It's never actually come to fruition. Okay, so for one thing, it definitely didn't update here. I guess that's because we're never changing it, though, right? We do need to update it. So we do need to call, like, we need to update it at the time that the game over happens, which is after check winner. So we do want this here, maybe. You can say session score text.text equals. And we go again. We're going to try to get it all over I2C controllers, i.e. not require the main processor to have them both. Nice, but I have a small secondary. I was just playing, actually, the other day with I2C target and I2C, whatever the main one is called. Maybe main and target? I don't remember the new names. But I was just playing the other day with, like, the most basic version of sending data and or commands back and forth over I2C between two microcontrollers so that you could kind of take one microcontroller and make like a breakout that does some complex thing at the direction of another microcontroller via the I2C bus. So you kind of like make your own breakout out of a microcontroller. I only did the most very basic bits, though, just managing to send a couple of bytes back and forth and receive them on either end, and that is it. But it did work, which was kind of cool. I've never done any kind of like lower level I2C stuff myself, like only just using driver libraries that internally, you know, have I2C communications. But I've never actually worked on one of those driver libraries or done that communication like more manually rather than with a helper driver. All right, so that does look like it worked. Let's make sure that the O's work as well. So we'll give O's a win here. I don't know why I moved down. There we go. Nice. And I mean, I don't have any reason to doubt that it would work, but let's just make sure that doing a second win for either of them works. So I'll give X another win here. I would like to get that to like skip past the occupied. Is like when you're allowed to get the cursor on one that's occupied and then you can't see it. Which I guess, like, maybe the piece is just on top of the selector, and I guess I could put the selector on top of the piece, but ideally it would skip past it because you're not allowed to play your piece there. Did I add a check? Let's check the 2 first. Okay, yeah, 2 is working. Let's make sure that it doesn't allow you to play on a spot where there's already a piece. I don't think I've checked that before. You can double tap on move things, and it will like automatically move the second time afterwards. It can't like, it can't stop refreshing once it starts, so you have to wait for the first refresh and then the next refresh. But if you do press the button twice, it will at least like move after the first refresh. All right, let's get the terminal here as well. Yeah, that totally just lets you clobber it. All right, yeah, let's add a boundary for that. If you do a skip, then you have to have edge detection. Yeah, that's the problem, is it's like, I don't want to add too much to the code, right? Like, I don't necessarily want 20 or 30 lines of logic or anything to just get it to jump to the next empty spot. And the next empty spot is actually not necessarily a trivial problem, but I will say the coordinate space is so small, we could probably just brute force it relatively easily, but I don't want to add too much complexity. Part of this is also to make a relatively basic example that could be handed off to somebody else at the conference who maybe has one of these badges, but not as much experience, and like we want the code to be easy enough. Which is what scares me about trying to do the kind of like hop ahead to the next empty space logic. It definitely could work, but I don't have confidence in my own ability to write it without it ending up adding like sort of complex chunk of looping and checking and doing some weird stuff. Because it could be like there's no empty space in the direction you moved, and then like it might need to change directions also. But we also want it to like choose the most logical place. So if the player pressed right, we don't want it to change directions unless it can't go right. Like we want it to start by checking right and then only change if it has to. I don't know, maybe it can be distilled to not be too complex. I'm not sure. I don't have a clear vision of how the logic would end up having to look. In my head, it's on the complex side, but so do we want to add a check right here before we call play current move, or do we want to add a check inside of play current move? So basically the choice of that is like, do we want the API to be resilient about breaking the rules? Or do we want the logic outside of the API, the actual game logic? I think I want to keep the game object able to do that, because you could maybe like make your own new version of tic-tac-toe where sometimes maybe you are allowed to like overtake a piece or something, right? Like tic-tac-toe is a pretty basic game that most people I think have solved basically, so it's like not very fun that much if you are playing with two people who know how to play. You know, maybe you want to try to shake it up and change it to where you're allowed to like clobber a certain number of pieces, or like clobber pieces in certain positions or something like that, in which case it'd be nice if game will just allow it. You know, you could still add your own logic outside of that to enforce whatever other rules you want, but this makes it flexible if you did want to go that route. So let's go here and let's say if what is that? Game state, I think. Or board state? board state, but it's on game, so we need to say game.boardState. And then we want to be accessing the current position. Let's just go inside of here because so one thing I don't know though is if that's like XY or YX. You just need to be like this though. Let's start by just printing this. All right, so if we get the correct thing, then those are probably in the right order. But if we get the wrong thing, like blank, then they're probably swapped. What I'm going to do is play something at a location. Then I'm going to go back to the same location. It would be cool if we could skip, like I doubled up. It would have been nice if we skipped the middle one. We can't like cancel a refresh very easily though, I don't know. Okay, yeah, so it said selected and then it's an empty space, which is wrong. Makes me think these are transposed. Now we should see the X, right? Yeah, there we go. Okay, now we got them in the right order. We're going to say if that is empty, we're allowed to play. Do we, maybe we just print or? Great way to learn state machines and recursion limits. You do a skip, then you have to have, oh, right. Yeah. Machines and recursion limits. A little big. Oops. Okay, so we get nothing on the display, but we did get our little warning there. Can't play on occupied space. Okay. The other thing that I would like to add is a ongoing score. So the session score, this should be resetting Well, the intention is that this should reset whenever we go back to the badge and then come back to the game. This should be back to zeros. Is that true, though? It probably won't be right now. Oh, okay, that was my any key to reset accidentally, but I wanted to go back to here. Okay, and then we can go back. Yeah, so that does not reset. So I want to reset the session score whenever we change from the... Whenever we go back to the badge. Here. Oops. We don't really need to replace the whole dictionary. Reset those to 0. But I do want to also keep a overall score. I might just take the word score out, or I think what we'll do maybe is put score actually at the top and then put session below that. And then we're going to have another grouping over here that's going to say all and is going to have another X and another O and another 2 numbers. So it'll say score and then session and these 2 and all and then these 2. Because I also want to keep track of the score in between the sessions too. We're going to use NVM for that. Is there a better word for session? Round, maybe? I think let's call it round. It's a couple, 1 or 2 letters shorter. I'm going to basically take all of that. We're going to make another one, but that's going to be the all score template. It's like all time, basically. This one will not have score at the top. We're not going to duplicate that. Just going to say all we'll say all score or all, should I, yeah, all score, all time score? I'm gonna say all time score. Rounds total. Yeah, I think I like this other orientation better a little bit. For my own brain, at least, personally. All time score. Or no, I can't really articulate why, but the columns, I like the columns being the different modes rather than the columns being the different letters, different pieces, different winners. Yeah, this doesn't exist yet. Score, I'm just gonna make an empty dictionary to start with, and then we'll fill that in using some fun stuff. Ah, shoot. Can't believe I did that again. I think I noticed it earlier this time. I don't know why, but it feels better, yeah. Like it's a top-down, left-right. It's like being left or right-handed. Yeah. That's a good analogy. I never thought about it that way. left-handed interface. Okay, this one will be a little bit lower. But I don't know the exact right value. I'm going to guess 10. This is still the all score text. Let's see how that looks. What? Oh, yes. The X will also need to change. What are we thinking there? So 296 is the total. So, I mean, we have anchor point, actually, right? We could just say... 1.0 there, and then we could say display.width minus 2. This is the wrong one. there. Display.width minus 2 there. So that will basically align it to the right side of the display, rather than trying to figure out the right pixel for the left of the label. That moves it all the way over to there. I do want to be going down some more. Quite a bit, actually. We could put an empty line. It feels janky, but it would make it line up perfectly. So I just put a new line above there, because on the other one we had score up there. So we put that new line, it will actually, it should take the same amount of space as score vertically, so that all and around are aligned now horizontally. Nice. Cool. All right. In order to be able to save the score between the different rounds, we are going to pull up the NVM helper. Hello? Oh, there we go. Why was there no like loading indicator? What's up with that, GitHub? Come on. Give it the old circup install action right there. Whoops, I accidentally closed that instead of clicking it. Well, bam. Maybe it would be Foamy Guy, I think. So it looks like I never put the right thing in the README. Yeah, that's weird. All right. I should probably take my name out of that. I don't know. I don't really know why I put that there. Like I had it in the name of the repo. It doesn't really need to be in the name of the library. It doesn't even really need to be in the name of the repo, honestly. Just like all the Adafruit ones are Adafruit CircuitPython. I took that naming convention basically. I think I might have even used cookie cutter prefix or whatever it calls that variable. So this, for anybody that doesn't know, NVM is for non-volatile memory, which is a kind of memory that can persist through power off cycles. So like RAM, whenever the device loses power, your RAM data is gone. It's whatever was stored in there is gone. You can't access it when it gets power restored. NVM, on the other hand, though, it's non-volatile, which means it doesn't need power to persist. So if you write some data into some NVM storage and then you lose power, get unplugged or whatever, the next time you power up, you can actually still read that data out of the NVM storage. So that's what NVM storage is. NVM helper is a library that lets you write arbitrary Python objects into CircuitPython's NVM storage, which is built into some, but I don't think all, devices, but ours does have a little bit, I'm pretty sure. And so we will be able to save an arbitrary Python object inside of it. In my case, I want to save a dictionary with X and a number, an O and a number, just like we have for our scores. And in order to do that, we are first going to read the data, see what we get. Hopefully nothing absurd. I don't think I would put anything crazy in there. Yeah, I mean, definitely not on this. I've used NVM to store Wi-Fi credentials before, so I'm hesitant about printing it, but not on this device, right? So it shouldn't be a problem. Let's just put this around here. Yeah, we can put this right around where we're setting up our all-time score stuff. So we read the data out of the NVM helper. We're going to print that out. It's going to be none or empty or I don't know. We're going to find out. EOF error. All right. So that's how it tells us that there is no data there, which is cool. So we can actually just say try, and then we can catch. No, we can accept, because we're not in Java, the EOF error. No data in NVM. So we're gonna we're gonna initialize it. We're gonna put the initial data in there. So let me take that, put that there. We don't really need to print it anymore. Okay, all-time score. Okay, so we can save it for the first time. So we can say nvm helper.save. I don't even know the API to my own thing. Save data. It takes the data, which is all-time score, and then you do actually have to pass test run false if you want it to actually write, which it does default to test run true. And the reason for that is because NVM storage, it actually has a limited number of write cycles. So I wanted to make, I made the explicit choice that the developer who's calling save data needs to pass the non-default option for test run in order for the write to actually happen, which is like not great from an API standpoint, but it's trying to save your NVM from write cycles that you don't intend, right? If you're first writing your code and you stick this into your while true loop, you know, you don't, like, that could wear out your storage to write it over and over. Change read data on line 332. Yeah. Yes, basically. Yeah, I was getting towards reading it again, but that's actually just better. We don't really need to read it again. We can just set it the first time. I do want to have none before. I don't think this might not be necessary, but in my mind it makes sense because it's like declaring a variable. And in my mind, the way these ones are inside the block makes them local to that scope, but I don't think it works like that in practice, but in my head it feels like it should, so I like having the none there explicitly first, and then, okay. That should be all we need. So read it. If it fails, then write it and start it on 0. That's going to give us back that object. So we just need to update it whenever somebody wins. All-time score +1, and then we need to save it at that time also. And we would need to update the screen too. I think that's it. No crash. Good. So, yeah, we'll get a win in the session, and then we'll break out of the session and start a new one and make sure that our all-time keeps our win. All right, so X's got a round win, and X's got an all-time win. It's any key to start the next game, and then it is hold A and press C to go back to the badge, and then it is press A to go back to the game. The round score did not update. Didn't we do that last time? We did reset that. Imagine that. About it. Whenever we go to the badge. Where we go to? Okay, so the thing is, we're not refreshing it when we go back to the game, which we need to. And we might as well refresh both, although we know the all score hasn't changed, so I don't know, maybe we shouldn't do that one. But session, we definitely need to refresh the session whenever we change to the game. All right, so set that text. Because that should be back to zeros. And then inside set state, somewhere it will call refresh for us. Probably. Our all is there, so that part's working. That's pretty sweet. All right, there we go. 1 and 1 all time. O's got a win. Any key to restart. It might be nice if we could get back to the badge from the game over state without starting the next game. Right now, when you're in the game over state, you have to press any key to start the next game, and then you can hold A and press C in order to get to the badge. But you can't just go directly from game over to the badge. You have to start the next game, which is like not ideal necessarily, but also not the end of the world either. Nice. All right, now we're back to 0 in the round, and we are still at 1 and 1 all time. I think the one more thing that I have in mind is showing those stats on the web server. So the web server gets spun up, and it's running on port 5000. Yeah, thank you. So if we go, I'm gonna leave that open so I can throw it in a list later to come back to it maybe next week or sometime. Then I distracted myself from here. Right, the web server, but I don't know the IP. It say? It does not, it just says zeros. Is it? Thought it would sometimes show there. I don't know how to get the IP address. IPv4 address. Last packed. You know how to get it from this unpacked thing or whatever, this packed thing? Oh, I did dir. Yeah, there we go. Thank you. I do want to restart that. What is packed? Doesn't matter. It's from port 5000. So right now the two things are index and then the RGB one. What I would like is on the index, I would like to actually fill in the all-time score. All right, so we're going to kind of make this into a bit of a template, basically. And then instead of a file response, we are gonna load our template actually before all of this. This is another one where because of that block, it feels like it's going to be scoped. So in my brain, it feels like it needs this, but I don't think it actually does for real, but... Oh, usage, yeah, that's fine. It's just how I want it, basically. Okay, and then here, we want just, I guess, a regular response, probably. Assume if we just put some stuff here, it'll be what it is, right? say all-time score X and all-time score Y. Should fill in the template for us. It might get returned as content type text. Might not render the HTML. Did I seriously just do a Y again? Goodness. Yeah. We need type. I don't know if that's a thing. We might need to use the header. Nope, that works. I did the format wrong though. I coded it here as though it was going to have a dot replace. But if we want it to work with format, actually, it should be like this. There we are, 1 and 1. Let's make sure it goes up. And then I think I'm probably going to call it there after that. Uh-oh. Why are we at 1 and 0 there? Yeah. It's stored as a packet byte structure. It's not what comes from the network. I gotcha. That is really weird. I probably have another Y somewhere, don't I? Or I did a 0 in 7.0? It said 1 and 1 earlier though, right? Oh, we're not setting it. Are we? Oh. There we are. Okay. Accidentally had that on session score still. So we got the X's from all time and then the O's from session. Are we storing to NVM at the round over stage? I am, no, I'm writing to NVM every time a game ends, and a round technically can contain more than one game. But I am writing to NVM every time a game ends, and then I am not explicitly writing at the end of the round. But if the round ends at the, after the conclusion of a game, then we will have written at the conclusion of that game. Oh, I totally meant to not do that. Okay. All right, there we go. We'll give them the damned if you do, damned if you don't move there. Bam. There we are. All right. I think I am going to stop there for today. So thanks for hanging out. Thanks for the help in the chat and all the questions and comments and everything else. I hope everyone has a good rest of your day. I will be back for sure next week at the same time, same place, Saturday morning, 10 a.m. Central Time, which is when I tend to stream here. I think I'll be doing deep dive, not next week, but the week after, maybe, I think Scott mentioned. So check out deep dive on Friday with Scott this upcoming week, but then I may fill in the week after that. And otherwise, I will bid you farewell and say thanks again for watching. Take it easy.